So I got a delivery from Farnell. We've got the little SOT23 devices here. So I couldn't get the original parts for this because the original parts are actually made by KEC and they're quite obscure. KEC is a Korean electronic corporation, electronic, I'm not sure. So I found some equivalents. These are made by On Semiconductor. So we've got the common cathode diodes. They're a similar current. In fact, these are a tiny bit higher and a little higher power dissipation. And we've also got the transistors, and these are internally biased. So, you know, internal biased transistors, which means they've got the two resistors. Okay, so I got the it's a power MOSFET, RF power MOSFET. It's the Mitsubishi RD16HHF1, which is a genuine Mitsubishi device, and we've got a 2078. Now, this radio uses a variant of the original. Now, this is an original, and this was actually made by Sanyo. And I've got some extra ones. So I've got a regulator transistor. It's a 2SB 1370. Yeah, 1370. I've just got this on standby. I tested the one in the radio. It looks okay. And I also got a pre-driver, which is 2SC 1314. I can't see it. But it's the correct one. That's also a genuine Sanyo device. So what I'm going to do first of all is fit the little SOT devices. I think the best thing to do is install them one at a time and just make sure they're working. Okay, so we're going to replace I don't know if you can see there, but there's 3 pads. I've removed the device, but it's a little SOT23 transistor, and that's what we're going to replace. And these 3 holes here, that is the actual main switching device, which I've taken out. I've just got to solder it back in. I've tested it, that's fine. It was obviously the problem was with the small device. Okay, so first of all, what I'm going to do is just clean this area. There's a bit of flux on there, but a bit of isopropyl, very gently. You've got to be careful with these. I don't want to knock any of the other surface mount components off. Now, somebody did mention that surface mount isn't that difficult, and it's true, it isn't. It's just you need a bit of practice at it. The best thing to do is get scrap boards and start, taking the components off and putting them back on. That's how I learn. And but you just got to be careful. What I'm going to do, I'm just going to put a little solder, just tin this first one, and then I'm just going to solder it in with a regular soldering iron. If you put heat on with a heat gun, which I don't have, you've got the danger of heat swelling the board, and there's all kinds of problems, damaging the other components. The other components start to swim, and you can blow them off the board. So I'm just going to put this in with a reasonably fine tip iron. little tad too much on there. I'll just take a bit of that off with the wick. That looks okay. Let's give it a bit. There you go. See, it's just like I bought one. Okay, so we've now got the PMP switching device, and obviously we know we've got the new transistor in there, and that's literally just driving this. And this controls the RX8. And what was happening before, as we went through in the last video, it wasn't shutting down properly. So the RX8 was still on when it was in transmission mode, or it had come up, and it was because this unit was breaking down. So we've got it set up as before. If I put it into transmission mode, yeah, we're getting a nice solid red light, because before that was giving us an orangey colour because the two diodes within the LED were coming on at the same time. So that seems to be giving us a nice, if I can do it, because I'm really shorting wires together, that's giving us a nice clean changeover. So the thing to do is just pop. I've got the meter set on voltage, and all I'm going to do is look at the RX8, and one of the easiest places for me to pick it up is in the front end. So I can see, where are we? Yeah, you'll do. Okay, so at 7.75 volts. I think we're on the other side of a diode, so that's why we've got a bit of a drop on it. Maybe, I'm not sure. No, that 8 volts. That's what it's given us. So if we key up, yeah, we're down to 7 millivolts, 8 millivolts, which is nothing. So that won't do anything to the receive, because it won't. It's not enough voltage to turn any of the transistors on. So that is working good. So what I've done temporarily is hook this. I don't know if you see that, but that's just a diode. There's another SOT23. That's the common cathode 2 diode pack, and what that does is switch on the upper and lower sideband carrier oscillator. So, and I noticed one side had gone open circuit for whatever reason. So the next thing I'm going to do is replace this. So that is the device there. We've replaced it. I had to remove this capacitor. I've just replaced that for a new capacitor. It's a 16 volt, 47 microfarad. I've just put a Nichicon 105C in there. It's these are very low ESR. It's for switch mode power supplies, but perfect. I'm not quite sure what that's doing, but I can't see it would be a problem in this set. Okay, so we can just see if this is working. There's a test point here, and there is it. Let's have a look. Gotcha, here, there. Okay, you can see that's making a waveform. We are currently on lower sideband. Now on upper sideband we're getting a waveform. So the frequency we're getting is 10.6925. That's on upper sideband. And we're getting 10.6976 megahertz. Not quite sure if that's right. This thing probably needs an alignment. There's a slight difference there in amplitude between the two. Again, might just be an alignment issue. I don't think it's going to make any difference. But that's working. If we go on to AM, that should disappear. Yes, it does. FM, it comes back on carrier wave, which is correct. Okay, let's move swiftly along. Okay, so the next thing I'm going to tackle is this driver transistor. That's this one here, which is a 2SC2078. It's an NPN RF power transistor. I think they're good for about 30 megs. This is a KEC version. It's gone, as you can see. I've showed you in the last video. It had obviously overheated. So there's a bit of a problem there. See, that's the underside of that transistor. And it's quite limited space to get in there. I'm not sure if I'm going to be able to do this without dropping this heatsink. I didn't really want to drop it, but it's looking more like I'm going to have to. Also, as well, I would like to have a look underneath here at the circuit board. But well, I'll try. I'll see if we can get it. See if we can get to it. If it's too restrictive, then yeah, the heatsink's going to have to come off. So as you can see, I've dropped the heatsink in the end. Yeah, it was just too much to get in there, and I'm glad I did, because there's a few issues under here as well. I taken the pre-driver out, tested it, and I've got the 2078 out. And if we take a look over here, that's the pre-driver. So if we can get it to focus. It's only a cheap Chinese tester, but they work quite well, these things. Yeah, that's checking out fine, you know. It's got plenty of gain in there, so that seems to be okay. And if we take... This is the 2078. Now this was giving me, you know, it tested okay, but it wasn't drawing anything. And then, let's see. See, that's testing as 2 diodes. So if you tested that with a multimeter, you'd probably think that was okay. But it's not. And the reason it's not is because it hasn't got any gain, because it's been totally fried, you know. You know, if we put let's take that out. Let's put a proper one, a good one in. It's hard to do things one-handed. Sorry. Okay. So yeah, it's got plenty of gain on it. So yeah, that's why we weren't. When I was trying to set the bias, that was it wasn't drawing anything. And that's why, is because its transistor had no gain. Other things of concern, I've noticed on the bottom of these power transistors, this is very, very dry. Yeah, when it goes dry, it loses its thermal conductive properties, you know, or it weakens. So that's not good. Other things of concern, I don't know if you can see that, but there's some little solder. Now this is a coil. I'll show you on the other side. Why that would be like that, I don't know. It says somebody's been monkeying around with that. See, that's the underside. Now that's got a little mica. What's the name? That's totally mashed up. So we're going to have to replace that. So I'm going to clean all this off. It has to all come off, and then I'll put some fresh thermal compound on it. I think we put it together. Also, there's a little problem. I don't know if you can see it. It's like someone's been messing about here. There's a capacitor. There's a capacitor on the other side that's broken off, so I'm going to have to replace it. Yeah, this is the capacitor here that's it's broken off. I'm not sure what value it is. It's just a disc ceramic capacitor. I've got quite a few in stock. I'm sure I can find one that'll do that. And that's the coil. I don't know why somebody's been monkeying around with the coil there. That's part of the low pass filter for the output, which is there to stop spurious emissions, harmonics and such like. And it also does, two jobs, and it matches the impedance to the antenna. You know, I don't know why. I think somebody's been trying to get more power out of it. I think that's the whole thing with all the damage and everything. I reckon these are fine. And there's two reasons. One is that they go short when they go. And two, which is another very good reason, is this transmitter driver stage isn't strong enough to drive these anywhere near their potential. So I think they're rated, the radio's rated, I think it's 100 watts or 80 watts on single sideband, and then I think it's 40 watts for AM, probably 50 for FM. But these are capable of a hell of a lot more than that, and I think somebody's obviously thought that, yeah, okay, well, we fiddle around with it, we'll get more power. You won't, because you know, you'll blow this up. And also, what's strange, you're using a MOSFET to drive you know, bipolar transistors, which, you know, it will work. Obviously it does, but it seems a bit odd. And I normally put a setting. So what you normally have is two devices of this size, balanced, driving two devices of this sort of power, you know, and they've just made this single-ended. So I imagine when they designed this, you know, with the nature of this type of radio, that they obviously didn't want to see them coming back, because these, having to replace these, would take any profit they would make on the radios, because they're quite expensive. So I think they've deliberately designed it so they've monkey-proofed it. So yeah, there you go. Okay, so I'm going to change that. There's nothing else around here. I've got a rebuild here. There's one little bit that it says in the diagram it needs a diode, which is it's a bias limiting diode. On a MOSFET, it doesn't make any sense. So I'm not going to put that in, because MOSFET's the high impedance inputs, and they need about 6 or 7 volts to get them to go. And a bias limiting diode is going to limit you to about 600 millivolts. And I'm just going to put a bit of copper. I've got some copper foil on here. I'm going to replace that. And that is that's the gate of the MOSFET. So there's very, very little current there. So there's no load going to be on it. So I'm going to put some of this foil tape I've got and cut a fine piece. I might araldite it in there. And okay, so now I'm gonna fix this transistor in, reassemble all this, fix the capacitor, and put it all together. Well, she's back together, and if we turn it over, I've got the heatsink obviously back together. She's all the compounds in there, and we've fitted the driver transistors. They're all installed with new mounting kits. Okay, so we've got a trimming pot here. That's for the bias setting for this device. So the circuit was actually calling for a diode to be in there, which looked like a bias limiting diode, but you would never use those with a bipolar. You'd only use those with bipolar transistors. You wouldn't use it with a MOSFET. As I say, these things expect to see, you measure it in voltage, but the gate voltage, that's basically what you measure. That's how I normally bias them anyway. So yeah, of course it's got a mounting kit with insulators and stuff, and the same. If we look here, and this is the 2SC2078, which obviously drives this bad boy. That's in again, a new mounting. I've used silicon rubber. These are the thermal transfer pads rather than mica. I haven't got mica. It's a bit of a messy old business, but yeah, these work really well. So yeah, that's what's installed. So the only thing left to do is put some juicy Lucy on it and see if we can set up the bias currents correctly. So we are set to sidebands. I've got a little plug plugged in the front. I don't think you can see that. That goes into obviously the mic socket, and what we're going to do is put this thing into transmit. Now there's some little jumper things you can pull off here, and what this does, this is the supply, it's the collector current to the various devices. So we've got this one, which I'm currently in testing for now, which is for the driver or I get confused with this thing because of the diagram. I call this a pre-driver, but it doesn't matter. But we're going to measure these currents. So what we're going to do is put it into transmit. Obviously, there's no audio sound. I've got there's nothing going up the mic audio path, but I've got the mic gain turned down to 0. And what I'm going to do is put it into transmission mode. We're measuring the current. We're set in milliamps on the multimeter. So we key up. Now we're pulling 58 milliamps. The service manual is calling for 60 milliamps. And if you can see, if I just adjust that pot now, it is quite finicky. But you can see I'd obviously set it. But that's sitting quite happily. Okay, so now we are testing the power MOSFET device. This is the device that drives the big transistors. I think it's an RD16HHF1, and we're checking the gate source current. I always get them mixed up. To set, and that's basically to set the BIOS so we can keep the stage reasonably linear. So we're setting sidebands, power set to high. I think all we need to do, we're trying to get 1500 milliamps on here, and for those of you playing along at home, that's 1.5 amps. And if we have a look, she's drawing 1.57. Yeah, and you see if I adjust the pot now, this is the pot I've installed. You can see. So I'll just back that off to, there we go. That's about right. Okay, so that's good news. The next thing to do is get it on a power meter and see if it will produce any RF.
Lazarus. Come forth!
Okay, that's quite enough of all that. Okay, as usual, I normally over dramatise things, but there you go. Okay, so I've tested the radio. It's transmitting. It's fine on all modes. There isn't a problem. It can quite easily produce 100 watts on sideband, which it is doing. It basically needs aligning now. Now, the problem that we've got is a lot of these little tiny trimmer variable resistors, they're all shot. I've noticed that, you've only got to look at them funny and they'll turn. I think it's a combination of two things. There's obviously someone twiddling with them all the time, because in reality, they only need setting once at the factory, and that's it. You know, this whole notion of constantly fiddling around with radios achieves absolutely nothing. You know, it's nothing tangible. So it's, you know, and the actual action of doing it, you know, it damages things. And these are, I think the second thing is they're not very well made. I think they're just cheap. In fact, you know, the build quality, yeah, the design build quality seems okay, but the quality of the components, some of these components they've used really is bad, and you know, so consequently it leads to these sort of problems. So I'm going to have to make another order and order these. There's no point trying to align it with these in. Now I replaced one here. This is obviously a through hole trimmer, and I've just tacked it on carefully, but it's not really the way to go. It really wants you know, the proper trimmers of reasonable quality. Now I made this order to Farnell, and the parts I'd ordered cost very, very little. So, and I was thinking, what else can I order here just to make the order up to cover the handling fee? And I'm sure they've got them. So I'm going to make an order and get a load of pots. But there isn't very much wrong with it now. It all seems to be there. It all seems to be working. I did have a go at aligning it, and a lot to do with the power levels. As I said before, somebody's clearly been, you know, the objective of what they've been doing is trying to get more power out of it, and consequently they've actually destroyed the radio. So, you know, it's just a false economy, you know, thinking that these people think that they can do it. And the damage, you know, it's just time consuming trying to patch it all up. You know, and it's not good, you know. Well, look, I'll get off this. I'll get off my soapbox, but yeah. So that's all it needs, and it just wants an alignment. So I may possibly make another video on this if people want me to. Let me know in the comments. Otherwise, I'm just going to order the parts and put them in, and then it's back off to you know, the Emerald Isle. So. So, you know, that's it. Well, if you've watched all the series up to now, I'd just like to say thank you very much for watching. And please, you know, think about liking and certainly subscribing, because it does help the channel. I don't have many subscribers, and, you know, every little helps, you know, and it encourages me to make more videos. So there it is. Okay, well, thanks for watching, and we'll catch you next time.